Hey everyone, we're going to start systems of equations today. This is the major part of our bundle. So some basics about systems of equations. A system of equations is a set of two or more equations with the same variables There's different ways to classify systems, and you probably have not learned this before. A system is considered consistent if it has at least one ordered pair that satisfies both equations. Okay, so let's write a note. This would be one solution or infinite solutions. Okay. A system is considered inconsistent if it has no ordered pair that satisfies both equations. And this is going to be no solution, or a set of parallel lines. Okay. And I'm actually going to add something up here. Infinite solutions is also when they are the same line. A system is considered independent when it is consistent and it has exactly one solution. A system is considered dependent when it has an infinite number of solutions, when they are the same line. Solving systems of equations using graphing is what we're going to talk about today. Graphing systems of equations will produce approximate answers, but the graph can help you classify the system by the number of solutions. There are three possibilities. The lines intersect at one point. 2, the equations represent the same line. Or 3, the lines are parallel and never intersect. Okay, so when lines intersect at one point, that one point would be right there. Okay, this is where I want you to grab out a highlighter. If you didn't pick one up from the back of the room, they're back there if you need one. Okay, so these systems intersect at one point. There is one solution. Everything I highlight, you highlight. There's one solution. And when there is one solution, it is consistent and independent. Okay. These lines will have different slopes. And you're not always going to see that until you get it in slope-intercept form. Okay. All right. The second possibility is that they graph the same line. Okay, so these two equations right here, they don't look identical, but when you put it in slope-intercept form, they become the exact same equation. So the lines are identical, and there are infinitely many points on that line. So we're going to highlight again. I'm using different colors. You don't necessarily have to, but you can. So infinitely many solutions are consistent and dependent. That's going to bother me. Oops. Consistent and dependent. Okay. And here the third possibility is the lines are parallel. This is another case where they don't really look identical. Well, they kind of look the same, but you don't know about negatives, positives, all that jazz. So when we put these into slope-intercept form, the slopes are the same, okay? These lines have the same slope and different y-intercepts. All right. This one means there are no solutions. And if there are no solutions, that system is inconsistent. Okay. No solutions, inconsistent. All right, now it's time to do some algebra. So the first thing we want to do is put these in y equals mx plus b. It's a good idea to write, I call it keeping your eye on the prize. So write what your equation's supposed to look like so you can see when to stop. So x minus y minus 4, I need to move that over here so I have some room to work. All right, so I need y equals mx plus b, so I need to get the y by itself. And we did this a little bit when we graphed in the last bundle. Y doesn't have any numbers with it, but if I just add y to both sides here, I actually have slope-intercept form, but I'm going to turn it around here. Okay, so there's that one. Grab another color. And bring this down here. 2 equals x plus y. Okay, it looks like I can get y by itself pretty easy if I just do minus x. So 2 minus x equals y. I'm going to change that around for slope-intercept form. Y equals negative x plus 2. Make sure everything keeps its sign. All right, now we're going to go over here and graph. So let's graph the blue line. Oops. Remember, this slope is 1 over 1. So I'm going to go down 1, 2, 3, 4. And then I go 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You don't need to make this many points, but my cat is jumping over me because I need to feed him. And I want to draw a straight line. Perfect. Okay, so there's the blue line. Now let's look at the purple line. Oh, one thing I was going to mention. Remember, this direction is positive, this direction is positive, this direction is negative, this direction is negative. Sometimes it's a good idea to write that on your graph. Okay, so negative x plus 2, I'm going to go up to 2. Then I'm going to go down 1 over 1. It's a negative slope line, so it should point to the left. Oh, my line's crossed. I see where my solution's going to be. So, let's see if I can do it this way. Okay. So I see my solution now is at 3, -1. So I'm going to write that over here. And then, okay, so this has one solution. So I'm going to look back at my notes. One solution is consistent and independent. Oops. All right. Oh, let's talk about it. Okay. So give you a second to get caught up. So there's that. One solution, consistent, independent. Got it. Next one. Okay. So let's turn these into slope-intercept form. Negative x plus 4 equals 2y. Ooh, it looks like here all I have to do is divide by 2. Okay, this is the part that always trips you guys up. This is -1/2 x plus 2 equals y. And I'm going to turn it around. I'm going to grab another color here. And pull that down. 12 equals -4y minus 7x. Let's see. I think I'm going to move that x over here. And do 7x plus 12 equals -4y. Divide everything by -4. And I get y equals -7/4x minus 3. I know. I'm going to be late. I'm sorry. Okay, let's graph these. 2, and then down 1 over 2. Oops. I need to do it so it makes a straight line. There we go. Okay. And then this one starts at -3. And then we do -7/4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay. I see where they're going to intersect. Okay. And there's my answer at 1, 2, 3, 4, 1, 2, 3, 4, negative 4, 4. So that goes here. And this one has one solution just like our last one, so that's going to be consistent and independent. Okay. All right, 2 more examples. I know I'm going slow. I'm sorry. Okay. Here's this one. Negative 12 minus 6 plus 2y. Negative 12x plus 6 minus 2y. Was that what I said? Yep. Equals 0. So we need that y equals mx plus b. So it looks like I can just add 2y to get y on one side by itself. Yep, and then divide by 2. So I have negative 6x plus 3 equals y. Turn it around. And y equals negative 6x plus 3. Okay, let's do the other one. I'm going to send this one down here. Oh, so much better. Negative y plus 6x equals 2. Y equals mx plus b, so I'm going to do minus 6x from both sides. Don't forget to bring down the negative y. Y, oops, now I got myself all confused. Equals negative 6x plus 2. I don't want negative y, I want positive y, so I'm going to divide by negative 1, and I get y equals 6x minus 2. I feel like I made a mistake. Okay. Plus 6. Goodness gracious, Shipley, you copied the problem wrong. I bet you guys all were trying to tell me, weren't you? Oh, okay. I'm not even starting the video over. I'm sorry. I'm tired. Negative 12x minus 6 plus 2y equals 0. Okay. So when you rewrite the problem, double check, make sure you did it right. Now I'm going to subtract 2y again. Negative 12x minus 6 equals negative 2y. Divide by negative 2. 6x plus 3 equals y. Y equals 6x plus 3. There we go. Okay. See? Everyone makes mistakes. Okay, so the blue line is going to be, we're going to start at 3. 1, 2, 3. And I'm going to go up 6 over 1. 2, 3, 4, 5. I ran out of room on the graph going up, so I'm going to remind myself that when the slope is 6 over 1, that could be positive 6 over positive 1 or negative 6 over negative 1. That's important to remember. So I'm going to turn around and go the other way, down 1, 2, 3, 4, 5, 6 over 1 in the negative direction. And draw my line. And then minus 2, 6x. 1, 2, 3, 4, 5, 6, 1. Oops, that's not right. Shipley. 1, 2, 3, 4, 5, 6, 1. Okay. All right, so ding, 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 we have parallel lines. The slopes were the same. Okay. So that means there is no solution. And pretty sure I remember, yep, it's an inconsistent system. Okay. One left. I bet you can't guess what it's going to be. All right. Let's do our work here. Let's make sure we copy the problem right. 3x plus equals 2 plus y. 3x equals 2 plus y. I need y by itself. 3x minus 2 equals y. Turn it around. Y equals 3x minus 2. Let's do this one here. Okay. Negative 2 equals negative 3x plus y. Okay, need y by itself, so I can add 3x. 3x minus 2 equals y. Turn it around. Y equals 3x minus 2. They're the same thing. Same thing, same thing. Okay, so graph that. Definitely, if you get this, somehow show that you have graphed 2 lines on top of each other. If it's a thicker line, just make sure you graph something. So what am I in? Purple. So we'll go down 2 and then up 3 over 1, 2, 3. And then I'm going to graph the other one right on top of it. I know it's the same thing, so I'm just going to do this. So there are infinitely many solutions. And, oh, I forget the classification. I know it's consistent. Chester, it's consistent and dependent. Okay. Well, there we go. Your assignment is a quizzes. I'm not sure how many questions because I haven't made it yet, but I won't go too crazy. You guys have a lot this week. I'll see you tomorrow. Bye.